Hello and welcome to yet another day at the Div. This is the third week already, and we are excited about the lineup we had so far. We still have a couple more days to go. Stay tuned. Today, I'd like to introduce you to Keshav and Runak, who are at the Mahindra United World College in India. And we'll talk to you about how the fourth industrial revolution is changing education. And with that, I'm going to hand you over to a live event. So there's going to be live audience, live questions, presentation, and a little maker session, a very practical approach to showing you what they mean by make in schools. They're both the founders of this movement. And with that, I think we'll hear more about from making more to consuming less. And with that, I'll hand you over to Runak and Keshav. Welcome to the Div. Thanks very much for the session.
Okay. There are a number of ways that Homo sapiens stands out from other species in the animal kingdom. We're bipedal. We have more creases in our brains, which mean more neurons and more synaptic connections. We have opposable thumbs, which allow us to grip things. Combine all of these biologically unique features, and you get one ultimate advantage. Human beings are born makers. Our superior tool-making abilities have always proved an advantage and have helped our rise to the top of the animal kingdom. And even today, our cultures and civilizations are built on our creative spirit. Societies all over the world value engineers and inventors as much as they value visual artists and musicians. And as our knowledge and understanding have become more sophisticated over time, so have our tools. Whether you look at the spinning Jenny and the 808 drum machine. And I'm a senior at UWC Mahindra College.
My name is Keshav, and I'm a senior at the United World College of India. As humans, we want everything to be easy. So we started something called consumerism. But buying, things started to become a lot more simpler. And no one had to start their own fire by using rocks. People didn't have to whip their horses to travel from place to place. And now people even don't need to walk to the grocery store to buy vegetables. Everything is online. This started destroying our idea for innovation and make. Robert Gordon, a current economics professor and the writer of Rise and Fall of American Growth at Northwestern University, predicted that the average American growth will drop to 0% by 2030. And so far, his predictions have been right. It has already been dropping down to 0.22% per year. What's sad is that this isn't just applicable for the United States. It is applicable for the entire world. There is innovation today, sure, but the rate at which innovation and progress has been significantly decreasing over the past years. We buy whatever we want, and that started making our thinking capabilities in so many ways a lot more or less significant. This has not just destroyed our ability to innovate and think, but also destroyed our ability to progress. Mass production was what was invented back in the 18th century. Factories started producing a large number of homogeneous items and products that made lives a lot more easier and simpler. This idea of mass production grew to become the third industrial revolution, taking the world by a boom. It fed into the lack of innovation and actually started falling out of the idea of make. So let me move on to actually the solution to all of this and what we consider to be the fourth industrial revolution, the maker movement. The solution to this problem was perceived by an MIT professor, Neil Gershenfeld, who started realizing that a lot of people did not actually understand that they can not apply their theoretical knowledge and they cannot really apply what they have learned in class into real-world application. So what this professor did was created a course called How to Make Almost Anything. this course, once he started out, students started enrolling. And the students who started enrolling were not just science and technology students, but also students from literature, from art, from history, and the humanities. What he understood from this was that the maker movement doesn't just feed into what we know as science and tech and engineering, but also students and people who actually fall into all the other categories. So it doesn't mean that if you want to be a maker, you have to be someone in the science and tech field. It could mean that if you have an idea and a passion for an idea and you want to pursue it, you can fall into the maker movement. So right after he introduced the maker movement using this course, he started designing something called a fab lab, a fabrication laboratory. A fab lab is actually a small-scale workshop, allowing digital fabrication. And these fab labs act as heads of the maker spaces within different communities, within towns and cities. These fab labs contain high-tech tools that can actually help and be useful for a lot of students, adults, and people who are interested in building the products that they want to build. Makerspaces are places that have much more rudimentary tools. It's for people who are actually amateurs and people who want to just start out with the maker movement. It doesn't just necessarily have to fall under anything that you've learned in class, but it could be literally something that you found out while you're going for a stroll or having a cup of tea. So these makerspaces turned out to be a complete boon today. And what we're trying to understand is how education can actually be a space for us to introduce these makerspaces as well.
The big takeaway from this mini history lesson is that hardware, like software and information before it, has been democratized, which means that it is now accessible to everyone. Like the internet and the open source revolution, modern day tools and technologies are now available for everybody to use, either for free or with a nominal cost. Fabrication and prototyping have gone from the realm of manufacturers and corporations to something that you can do every day. And this has largely been possible because of the scaling down and the fall in prices of different manufacturing tools, right from CNC milling machines to 3D printers. Now, one would think that with these kind of tools at our disposal, we would be able to come up with a number of different solutions to all of the problems that we face in our time. We could possibly have, say, an energy efficient water pump that's able to bring water to remote areas, or a soil monitoring system that is able to collect soil data and provide it to farmers. But like the internet before it, these high hopes did not exactly pan out. What happened with the internet was that it was expected to be this ultimate form of knowledge, a place where scientists, artists, and intellectuals could discuss their fields of expertise, and others could either contribute to the conversation or simply sit back and watch in awe. But what the internet turned out to be was this utterly random overload of information that everybody likes and consumes. And that is why when you might have websites like Wikipedia and Change.org, but you also have Salt Bay and Big Shack. Similarly, while we might have an energy efficient water system or a soil monitoring system, you also have giant muffin cars or even like 3D printed pancakes. And that's to be expected, because this is where the personal fabrication comes in. The entire point of all of these tools being available to you is that you're able to do whatever you want with them. You are the producer as well as the consumer. The cycle begins and ends with you. And that is where the true revolution lies. That is why the maker movement is the fourth industrial revolution.
Right. So we want to share a story with you, something that has impacted both of our lives significantly, and something that basically initiated the whole process of the maker movement by both of us. So we study at a residential school in the middle of a biodiversity reserve. And we're filled with a lot of flora and fauna. But one huge problem that we face every year during the months of February, March, and April is bushfires. So these bushfires happened to occur because of various reasons. One being from the sun, two being from people around the village who do it for a lot of religious and mythical reasons. And this problem has been something that has been occurring for the last 10 to 12 years and has been something that's extremely problematic for a lot of us. So we realized that this problem was primarily because of the inefficient fire detection system that is present on campus. So basically how this works is that the security guards on campus will smell the smoke, run to different locations where the fire could possibly be at, locate the fire, come back, and switch on the fire alarm, wherein the fire service team runs to the location and then beats it out. We've had situations where the fire service team has beat out fires for over 8 hours, and this process seems to be in no way an actual solution, but rather a band-aid to the beating. So what we decided to do was to build a drone. A drone that basically patrols around campus 7 times a day and uses infrared imaging to detect a fire, whether it's at a particular point with a perfect GPS location system. And what we actually gained out of this was that all of this came about just because we had an idea with literally no experience, 2 teenagers, along with a bunch of other friends, going to a makerspace in Bangalore and building something that we truly believed in. This leads me to the next story about a project week that Ronak organized in February. Over at UWC Mahindra College, we actually have something called a project week that is a week that's designated in the year where we work on a project that we're passionate about and do what we think will help the community. And what this project week, what the project week that we participated in was a project week in which we went to a makerspace in Bangalore and decided to make different projects that might be worthwhile for us and might be something that we could contribute to our community here. Besides the drone, we also worked on projects like a common room sensor that switches on and switches off lights as people walk in and walk out. Besides that, we also created a solar panel light that helps reducing the energy consumption at UWC Mahindra College. So we think a lot of it comes in from the way in which the maker movement has shaped us. And we believe that it was not just the maker movement shaping us, but also we shaping our very own maker movement.
So what is it like to actually be a maker and to live all of these ideas and these technological advancements? In fact, why did Keshav and I even decide to become makers? Well, perhaps the most important reason was that we actually wanted to see our knowledge in action. Both Keshav and I have always been interested in the sciences, but we've also always been looking for ways to actually translate our ideas into the real world. We love to unpack the world around us and to discuss it, but we're always not sure what to do next. And we not only want a way like in the humanities to engage with the people and the social systems around us, but we also want to figure out if our worldview actually counts for something. And this is where the maker movement comes in. It actually turned our science education into something much more fulfilling by providing us with the joy of actually building something with our own 2 hands. And by providing a hands-on approach to our education, we were able to understand our theoretical concepts even better while bringing our ideas to life at the same time. But most of the benefits that we received from the maker movement were actually pretty unforeseen. Each of the projects that we worked on in our project week required a different problem-solving approach, and that introduced us to the creative intricacies and the real-world importance of design. Good design opened us up to the possibilities of good problem solving, and it also showed us our creative uniqueness because of the different solutions that we came up with. Another key development in our learning experience was viewing failure as a pedagogical experience and not as the end of something. Some of the projects that we worked on at our project week went through 7 different iterations before we finally arrived at something that works. I mean, after all, we were just a bunch of teenagers with no engineering experience. Our projects were bound to fail. Our ideas didn't exactly take giant leaps from out of our minds into the real world. It was more of a sort of repeated leapfrogging with careful thought and consideration put into every step before it was implemented. The 3D printed landing gear for our drone, for example, also went through 3 or 4 different designs before we finally decided to go ahead with one of them. We realized that no one design is ever perfect, is ever truly perfect in its first form, and you have to mess up 4 or 5 different times before you finally realize that you have to start from scratch, and that's when you start iterating, and then you keep iterating, and you iterate every tiny microscopic element of your project until you finally arrive at something that satisfies your needs and that meets your expectations. So our desire to share, to experience this pedagogy on our own became a desire to actually share this experience with other people as well. And that is where Make in Schools comes in. Over the summer, Keshav and I started an organization called Make in Schools that aims to, as I said, share this pedagogical experience of a maker culture with other people. We aim to empower schools to nurture ideators and makers, up maker spaces on their campuses by carrying out make sessions and workshops with them, and by connecting them to local maker spaces and fab labs. The idea is to show students that the digital world is not isolated from the information that it represents. It influences the physical world as well. And by using the tools of the present, it is possible to use the digital world to manipulate the physical one, and vice versa. Most of all, we want to extend our experience to other people like us, and to provide them with what we think are 2 essential traits: the ability to collaborate and an affinity for good design and good problem solving.
So whether it was building drones or using CNCs to cut names for our room doors, the Maker movement has had a tremendous impact on our lives. Every human being has the ability to make, to build, and to create. And all of this together will help us solve some of the major problems that we are facing, whether it is climate change or whether it is world hunger. The main idea is for us to integrate this kind of a curriculum into our school education system. And for us, it is to utilize this resource, make progress, and make a difference in the world that we live in.
Thank you.
Thank you. So we'll be taking questions from the live physical audience, and we'll also look into the questions that are on the ThinkDiv website.
Questions? Yeah, Psychopath?
What was the most challenging experience you had when going through the iterating process for the drone that you guys worked on? How did that affect people?
So for Psychopath, for the online audience, Psychopath's question was, what was our most challenging experience with the iterative process with the drone? For me, it was just figuring out how it all came together and how the hardware elements actually integrated with the software. And there was actually a huge gap in our technical understanding when we first started out and when we finally finished with the project. And I feel like that was the most challenging part to iterate with, because while you're iterating with the design itself, you're also updating your own understanding of the way it works. And I felt like that was a very challenging but also a very rewarding experience. Yeah, Anne?
So you said that as a maker, you are user and the cycle starts and ends. I'm just curious, what about the waste steps? Do you think that all the things that are made are actually useful, or are there any byproducts that just
So Anne's question was that as a maker, it is possible for the cycle, for the production and consumption cycle to begin and end with us. But what about waste that is produced and things that are produced by the movement that are not necessarily useful? So that is actually a very valid concern. 3D printers, for example, make use of a plastic called PLA, which is melted, and the fumes are actually are highly polluting. and a number of other solutions are coming up, but PLA remains the primary form of plastic that is used for 3D printing. However, there are one of the key aspects of the maker movement is to actually adapt to like modern day problems, and climate change, waste, resource depletion, waste management is one of these problems that has come up, and that is why upcycling is a major part of maker culture in a number of places all over the world. So you find people using scrap metal to make jewelry, people using waste plastic to make containers, all sorts of projects that are demonstrated all over the world in different places. So even though there might be different flaws when it comes to sustainability issues in the maker culture, there is still, I believe, a conscious effort being made to deal with them. Any other questions?
Yes.
Another one.
So what are you doing in your own school?
All right, so Anne's question was, what are we doing at UWC Mahindra College to promote the maker culture? There are a few aspects that cover this question. So there are two main things that have been happening at UWC here in India. One is the creation of a makerspace on campus, facilitated by both Anne, our PBL coordinator, as well as the environmental studies teacher, and Ronak, who will be both working on creating a makerspace for us students on campus, so we can go and build the products that we were talking about. Besides that, PBL is actually a project-based learning certificate. And what the PBL facilitates is essentially a very similar maker idea, where you go in with a project and you have the resources and the facilities and the mentors for you to be able to work on that particular project, and also help in changing the way in which students approach education and promote a very project-based learning approach to it.
Okay. Any more questions?
Yes, I go.
Okay, so one thing which I have is that, like, you talk about setting up a makerspace, but the initial capital needed to set up makerspaces is obviously a lot, considering the technology that's needed to purchase and whatnot. So how exactly does your project make in schools, how does it try to overcome that challenge?
So Sagopal's question was how the price and the issues of how expensive setting up a makerspace is, to be able to promote it to all the Indian schools that are here, and how we can, how is it possible for us to be able to use maker schools as a tool to help promote maker culture, even though it's really expensive.
So that's where the connection with local makerspace and Fab Labs comes in. We know that it's not possible in every context and every situation to actually have a makerspace or those tools available in a school, and that's why makerspaces and Fab Labs exist in cities in the first place, so that people in the community who might not have the expertise or the money to afford those tools can come to them and use those tools either for free or at a nominal cost. And what we want to establish is basically a sort of educational relationship between these Fab Labs and institutions, so that they can come up with a sort of integrative experience that affects the way science, technology, and the arts are taught at these institutions.
It's also that the whole maker culture and the way that maker spaces organically formed back in the 2000s was through engineers and innovators coming and putting the tools that they have into one space. And because there were a large number of people who were contributing to this, that's what created this space to become a maker space. And we think that this can be also replicated here in the different places that we're trying to approach. And we haven't necessarily gone and approached schools yet. And this is what our task will be for the next coming months.
More questions? All right, we're gonna.
So we just looked through the online questions as well.
Okay, we do not have any online questions anymore. Thank you. Is there another question? Okay, no. Okay, thank you guys for coming. We're now going to be proceeding into the make session, which is for just 1 second. Sir. Okay, thank you. Yeah, we'll now be going into the make session that is for the live audience only.
But we'll just give a brief introduction to our online audience as well to give you an idea of how you can proceed to for you to start off with your involvement in the maker movement right at your house right now. All right. If you could open your laptops and your computers, what the website you'd have to go to is sketchup.com. So SketchUp is it's also an offline software where you can create 3D models for prototypes that you would want to design. And as you design these, you could technically give it to a makerspace and they will print it out for you. And this will be for the online audience who plan to use SketchUp.
Okay, so now I'm going to go into sort of the basics into using SketchUp and how you can actually use it to come up with a simple 3D design of your own, and how you can save it and then send it to us and we can get it 3D printed for you if you want. You can also go back and explore sort of more advanced skills in SketchUp so that you can come up with like an even more intricate design if you like. So this the human over here is for scale. I'm just gonna get rid of it now, and I'm gonna start with if you see this if you see. So if you see on the left hand side of your screen, you'll have one toolbar which basically has most of the drawing tools, and you can use those to draw all sorts of shapes, either in freehand or specific shapes that come in handy from time to time. So right now I'm just going to go ahead and draw a rectangle in one of the planes.
So this SketchUp can be treated as like a 3D version of Paint for at least the very beginner, for the very beginning. And from there, it can go all the way. It has the capacity to be able to design prototypes for even scientific and science, different types of projects that you want to design.
So if you can see the 3 axes on the screen, there's 3 different axes, and SketchUp allows you to draw on all 3 of them at the same time. And that's where sort of the 3D aspect of 3D modeling comes in, and it's really interesting to like manipulate your shapes and your design in all of these different axes at the same time. So I'm going to go back to my rectangle now. Now right under the same rectangle tool that I just used, there's another sort of icon which has like a little rectangle with an arrow pointing upwards on it. If you click on that and then click on the first item on the top, that's something called the pull item, and that allows you to essentially pull any 2-dimensional shape into the 3rd dimension that it's not in. So I'm going to use the pull function, turn this rectangle into a cuboid.
So just to quickly slip in other softwares that a lot of us use here on campus, and also for beginners in general. For Windows, there is Design Spark Mechanical that we use, and it's a very simple tool to use as well. And it can go as as deep as SolidWorks do. So all of those softwares can be used and essentially use the same type of technology to produce what you want and what you want to design. And for Macintosh, you can use a software called Cura, which also works on the same technology and can be used for all types of reasons along the same.
Cura is specifically for 3D printing. So you're able to import files that you can 3D print called STL files, and then format them a little bit before you actually print them. And it provides a number of features that are specific to 3D printers, such as how you want to slice the 3D model, for example, which is relevant for a 3D printer as it works on a slice-by-slice basis.
So as you can see, the cuboid, what you can do is you can just save it, and you can save it as a .stl file. And once you do that, you can go and give it to a local makerspace. And depending on your dimensions, they can print out a little small cuboid for you. And it doesn't necessarily have to be a cuboid. It could be whatever you choose to design and prototype yourself.
Yeah, okay.
All right. Thank you so much for watching. And you can leave your comments and questions on the same page on the thinkdiff.co. And we will get back to you as soon as possible. And we're extremely happy to have delivered a talk on both the maker movement and as well as our organization and how we want to promote the maker movement as a whole.
Thank you.
Thanks very much for that. That was very interesting. Taking away a couple of points here, which is tools of the present. 1 second, I'll highlight this. Using the tools of the present and affinity for good design and prototyping something physical from a digital perspective. These are the key takeaways, I would say. Thank you very much to Keshav and Runak for this. From the Mahindra United World College, keep on watching. You can view this video on demand over the next couple of weeks, and please keep on commenting if you have any directly speaking with our speakers on the website, on the session page. Thanks very much for that. Keep on watching on the next couple of days. One more point to make is designing the built environment, another session coming up. Future Out Loud Renewology. Check it out in our schedule. With that, I'm saying goodbye for now, and I'll see you soon. Thanks. Bye-bye.